In this video, we're going to review solving one-step equations. And before we get into some of our examples, we'll just review some of the vocabulary that we have learned about equations in the past. A variable is a letter that is used as a placeholder for a number. All right, and when we were working with expressions, in order to evaluate the expression, I had to tell you what the value of the variable was. But with equations, you're actually going to do the algebraic work to figure out how much that variable represents. To solve an equation, you are determining the value of the variable. That's our goal. We always want to know what the value of that variable is. Okay, so when we solve an equation, our goal is to isolate the variable term. All right, isolate the variable term and then get the value of just one variable. And to do that, we're going to use our equation's golden rule. When we have an equation, we have to keep the equation balanced. All right, that means whatever you do on one side, you're going to do the exact same thing on the other side. So for our equation's golden rule, do to one side exactly what you did to the other side. All right, so if you added 5 on one side, add 5 to the other side. If you subtracted 3 on one side, subtract 3 on the other side. If you divided one side by 4, divide the other side by 4 as well. Keep your equation balanced. Okay, so we're going to show our work algebraically, and we're just doing one-step equations here today. So one-step equations, all right, you can probably, with most of these, just look at the equation and figure out what the answer is. But again, we're going to focus on showing our work algebraically. So we have our equation that says y plus 4 equals 7. Some unknown value, when you add 4 to it, gives you 7. Our goal here is to try to figure out what y is, and in order to do that, we're going to have to isolate this variable term. The equal sign divides the equation up into a left side and a right side. You're always looking to see which side of the equal sign the variable is on, and in this case, it's on the left-hand side. Now, on the left-hand side with the variable, there's also this positive 4. We don't want this positive 4 to be there because, again, we're trying to isolate the variable term. So what we're going to have to do is, since we're adding 4 to the variable in order to isolate the variable, we're going to do the opposite and subtract 4. And if I subtract 4 on the left side of my equal sign, then I also have to subtract 4 on the right side of my equal sign so that my equation is balanced. Bring the equal sign straight down. And when we do that, on the left-hand side, 4 minus 4 is 0, leaving us with only the variable y. On the right-hand side, 7 minus 4 is 3, and so this says that y equals 3. The value of our variable is 3. To make sure, we're going to do an algebraic check. When you do an algebraic check, the first thing that you need to do is write down the original equation, which in this case, it said y plus 4 is equal to 7. Next, you're going to take the value for the variable that you found. Y equals 3. I'm going to substitute 3 into the equation. 3 plus 4 equals 7. And now I'm going to evaluate each side of the equal sign until I can't evaluate it any further. Now, the right-hand side already equals 7. I can't do anything to that 7. But on the left-hand side, 3 plus 4, I can evaluate. 3 plus 4 is 7. And now it says 7 equals 7, which is a true statement. 7 always equals 7. So I know that y must have a value of 3 in this equation. Okay, so that's what we're going to do here with our work. We're going to show our work algebraically, do the same thing to each side of your equation. Then we're going to check our answer on the right-hand side over here underneath the word check. Let's try it in example number 2. The equation 3 plus x equals 5. So here's your equal sign. Again, that divides it into a left side and a right side. The variable is on the left side of the equal sign, but it's not alone. All right, here's our variable, positive x. It's got this 3 with it, and that's a positive 3. 3 is adding x, and the answer is 5. So we've got to get x all by itself in order to figure out what that value is going to be. Since there's a positive 3 that we're adding with the x here, I'm going to subtract 3 so that my variable will be isolated. And if I subtract 3 on the left, I have to subtract 3 on the right of my equation as well. Equal sign comes straight down. 3 minus 3 is going to be 0, leaving us with just x on the left. And 5 minus 3 is going to be 2. X is equal to 2, I think. I'm going to make sure by doing my check. So first part of the check, rewrite the problem. 3 plus x equals 5. And now I'm going to substitute in my value. I think x is 2. 3 plus 2 equals 5. And now evaluate each side of the equation. On the left, 3 plus 2 I know is 5. On the right, I can't do anything with that 5, but 5 equals 5 is always a true statement. So I know that x does have a value of 2. In example number 3, n minus 2 is equal to 6. Okay, so again, the equal sign divides the equation up into a left side and a right side. Our variable is on the left side, but it's not alone. It's got this negative 2 with it. All right, so n minus 2 equals 6. I don't want this negative 2 to be here. So since I'm subtracting 2 from my variable, to isolate it, I'm going to do the opposite. I'm going to add 2. And I have to do that on each side. Equal sign comes straight down. And on the left, negative 2 plus 2 is 0, leaving you with the variable n. And it equals 6 plus 2, which is 8. N equals 8. Let's make sure with our check. Rewrite the equation. N minus 2 equals 6. Substitute in your value. We think n is 8. 8 minus 2. And now when we evaluate that, 8 minus 2 is 6. On the right side, that is 6. 6 equals 6 is always true. So we know that n has a value of 8. In our next example, we are told that x minus 4 is equal to negative 3. So here's your equal sign. Your variable is on the left-hand side of that equal sign, and it's not alone. It's got this negative 4 with it. We're subtracting 4 from x, and the answer is negative 3. All right, since we're subtracting 4 from the variable, to isolate it, we're going to do the opposite. We're going to add 4. And again, we need to do that on each side. Bring your equal sign straight down. On the left, negative 4 plus 4 is 0, leaving you with the variable x, and it's equal to negative 3 plus 4, which is a positive 1. X equals 1. Do your check now. Rewrite the equation. X minus 4 equals negative 3. Replace x with your answer. We think it's 1, so 1 minus 4. And now when we evaluate that, 1 minus 4, that's the same as 1 plus negative 4, which is going to equal negative 3. So negative 3 equals negative 3. The check worked out, and we know that x has a value of 1. All right, how about in our next example? Well, this time it says that 3x is equal to 9. Okay, now this example is different because in all of our previous examples, we were either adding or subtracting a variable and a constant. But in this example, 3 is multiplying x. 3 x's is equal to 9. All right, so this variable term is already isolated. There's no constant that I'm adding or subtracting with this variable term. So my variable term is isolated, but I don't want the value of 3 x's. I only want the value of 1 x. And so in order to figure out the value of 1x, since x is being multiplied by 3, I'm going to do the opposite and divide by 3. And I need to make sure that I do that on each side of my equation. Bring your equal sign straight down. On the left, 3x divided by 3 is 1x, or just x, which is exactly what we want. We wanted to know the value of 1x. And it's equal to 9 divided by 3, which is 3. So x equals 3, we think. We'll make sure that we did it right by doing our check. So we have 3x equals 9. That's the original equation. Substitute in your answer. We think x is 3. 3 times 3 equals 9. And now 3 times 3 is 9. 9 equals 9. The check worked out. And that helps us realize that x really does have a value of 3. How about in our next example? 2g is negative 8. So again, this variable term on the left-hand side is already isolated. There is no constant being added or subtracted to it, but we don't want the value of 2g's, we want the value of just 1g. So since g is being multiplied by 2, then I'm going to do the opposite to get the value of just 1g, which means I'm going to divide by 2 on each side. Bring your equal sign down. 2g divided by 2 on the left is 1g, or just g. And on the right, negative 8 divided by 2 is negative 4. So I think g is negative 4. I'll make sure with my check. 2g equals -8. Substitute in g's answer, which we think is -4. 2 times -4 is -8. And when we evaluate, a positive times a negative is a negative. 2 times 4 is 8. So this is -8 equals -8. The check worked out. And we know that g is equal to -4. Okay, so in the next few questions, I'm going to have you practice solving those one-step equations. So hopefully you have started to notice a pattern when you've been solving your one-step equations, okay? So if your variable had a number being added to it, in order to isolate the variable, then you needed to subtract the number from each side. So if it said x plus 5 equals 7, all right, you subtracted 5 on each side to get the value of x. If the number was subtracted from the variable, well, to isolate the variable, then you would have to add the number to each side of the equation. So if it said n minus 4 equals 8, then you would add 4 to each side to get the value of the variable. If the number was multiplying the variable, like 3n equals 27, all right, well, then you needed to divide each side by the number multiplying the variable. All right, so divide each side by 3 in that example. Well, this follows a similar pattern. If a number is dividing the variable, then what you're going to need to do is multiply each side of the equation by that number. So if we look at example number 16 right here, n is being divided by 4 and it's equal to 5. N divided by 4 equals 5. What we're going to do here, since our variable is being divided by 4, this is really 1/4 of the value of n. Okay, and I don't want 1/4 of the value of n, I want what the value of n is, 1n. So, since I'm dividing by 4 with my variable here, I'm actually going to multiply by 4, which is the same as 4 over 1. I'm going to multiply by 4 on the left-hand side, and I have to multiply by 4 on the right-hand side. This is going to help me get the value of n because if I look over here on the left-hand side, before I multiply my fractions together, I'm going to see if I can simplify. And I see that I can. I have a 4 in the numerator here. I have a 4 in the denominator here. 4 goes into itself once. So this is 1 over 1, which is just 1, times n over 1, which is just n. 1 times n is n. N equals, on the right, 5 times 4, which is 20. N equals 20. Okay, so since my variable was being divided by 4, I multiplied each side of the equation by 4 to get n's value. Let's do our check. Rewrite the equation. N divided by 4 equals 5. Substitute in your answer. We think n is 20. So 20 divided by 4 equals 5. And if you divide 20 by 4, you do get 5. 5 equals 5. The check worked out. So I know that n equals 20. All right. Now, looking at this example here, it was n divided by 4. N divided by 4 is the same as 1/4 times n. All right. Dividing by 4 is the same as multiplying by 1/4. And again, what we did here, all right, we multiplied each side of the equation by 4 in order to get the value of n. Well, looking over here at number 17, it says that 2/3 n is equal to 4. All right, I don't want 2/3 of n. I want the full value of 1n. So what am I going to have to do in this example? Well, if I remind myself over here, n divided by 4 is the same as 1/4 n. So if I had 1/4 n equals 5, what I did was multiply each side of the equation by 4, which is the same as 4 over 1. And looking right here, 4 over 1 and 1/4, these are called reciprocals. All right, these are called reciprocals. So what I did, the number that was multiplying the variable here, 1/4, I multiplied each side of the equation by 1/4's reciprocal, which was 4. That's the approach that I'm going to take here. 2/3 is multiplying n. To isolate the variable n, I'm going to multiply both sides of the equation by 2/3 reciprocal. The reciprocal of 2/3 is 3/2. So I'm going to multiply by 3 halves on both sides. And I'm just going to make 4 a fraction by putting 4 over 1. Now, if I bring my equal sign straight down, how does this help us get the value of n? Well, if you look here at the fractions, this is really nice. Before you multiply, you can simplify. 3 goes into 3 once. 2 goes into 2 once. So this is 1 over 1, which is 1, times 1 over 1, which is 1, n. 1 times 1, n, is just 1 n, all right? Looking here on the right side, 4 over 1 times 3 over 2, I can simplify with the 4 and the 2. 2 goes into itself once, 2 goes into 4 twice. So now it's 2 over 1, which is 2, times 3 over 1, which is 3. 2 times 3 is 6. So I think n is 6. I'm going to make sure by doing my check underneath. 2/3 times n equals 4. Substitute in n's value, we think it's 6. 2/3 times 6, which is 6 over 1, equals 4. And now let's see what we get when we multiply. Now, before I multiply, I see I can simplify with the 6 and the 3. Their common factor is 3. 3 goes into itself once. 3 goes into 6 twice. So it's 2 over 1 times 2 over 1, which is 4 over 1, or 4. 4 equals 4. The check works out. And I know that n has a value of 6. So again, if you ever have a fraction multiplying your variable, to isolate the variable to get the value of 1n, you're going to multiply each side of the equation by the fraction's reciprocal. Let's look at a few more equations that have fractions in them. We're going to look at this example right here. It says n divided by 2 is equal to 22. And remember, n divided by 2 is the same as doing 1/2 times n, which equals 22. Okay, so we have a fraction multiplying the variable. So in order to get the value of 1n, I'm going to multiply by the fraction's reciprocal. The reciprocal of 1/2 is 2, which is 2 over 1. If I multiply the left side by 2, I'm going to multiply the right side by 2 as well. And that's the same thing that we would do here. N was being divided by 2, so I would multiply by 2 on each side. Okay, so on the left here, I can actually simplify with my 2's. 2 go into itself once. So 1 over 1 times 1 over 1 times n, that's our 1n. And it equals 22 times 2, which is 44. Do your check to make sure. It was n divided by 2 equals 22 is the original equation. N we think is 44, so it's 44 divided by 2 equals 22. And if you find half of 44, you do get 22. 22 equals 22. The check worked out. So you know that n's value is 44. Let's take a look at this example. 3/4 n equals -12. So our fraction 3/4 is multiplying n to get the value of 1n. Then I'm going to multiply each side of the equation by 3/4 reciprocal, which is 4/3. So I'm going to multiply by 4/3 on the left, which means I'm going to multiply by 4/3 on the right. And I'm going to make -12 a fraction by putting it over 1. Bring the equal sign straight down. Look at the left-hand side. This is really nice here, all right? A number times its reciprocal is going to equal 1. 4 goes into 4 once. 3 goes into 3 once. 1 times n is n, 1n. And on the right-hand side, before we multiply, we can simplify. All right, 3 and 12 have a common factor of 3. 3 goes into itself once. 3 goes into 12 4 times, so -12 is going to become -4. So now it's -4 over 1 times 4 over 1. -4 times 4 is -16. Let's make sure that our answer is correct by doing our check. 3/4 n equals -12. Replace n with -16 since that's what we think the answer is. 3/4 times -16 over 1 equals -12. And now, before we multiply with our fractions, we're going to simplify. 4 and 16 have a common factor of 4. 4 goes into itself once. 4 goes into 16 4 times, so -16 is going to become -4. And now it's 3 over 1, which is 3. times negative 4 over 1, which is negative 4. 3 times negative 4 is negative 12. Negative 12 equals negative 12. The check works out and really does equal negative 16. In our next example, they tell us that 9 is equal to 3/8 n. So once again, I have my variable being multiplied by a fraction. To isolate the variable n, to get the value of 1n, I'm going to multiply each side of the equation by 3/8 reciprocal. Okay, now it's going to be tough to kind of sneak in the reciprocal right here. Remember that equal means the same. So I can actually just rewrite this as 3/8 n equals 9. It means the same thing. All right, and now I'll have a little more room. Multiply each side by 3/8 reciprocal, which is 8/3. I'm going to put 9 over 1. Bring your equal sign down. And now on the left, we can simplify. 3 goes into itself once. 8 goes into itself once. A number times its reciprocal is 1, so this is 1n or n. 9 over 1 times 8 over 3. You can simplify with the 9 and the 3. Their common factor is 3. 3 goes into itself once. 3 goes into 9 3 times. 3 over 1 times 8 over 1 is 3 times 8, which is 24. N equals 24. Let's make sure by doing our check that n is 24. So our equation said 9 equals 3/8 n. We think n is 24, so let's do the substitution. 9 equals 3/8 times 24 over 1. And on the left, that's still just a 9. On the right, 8 and 24 have a common factor of 8. 8 goes into itself once. 8 goes into 24 3 times. 3 over 1 times 3 over 1. 3 times 3 is 9. So 9 equals 9. And we know that n has a value of 24.